This talk is going to be a little bit weird because I'm someone who doesn't really come from a PHP day-to-day job, and I don't really do PHP every day. So what you hear will be the perspective of someone with that kind of background. And what I'm going to talk to you about is about how to put your relevance into the clouds with AWS Lambda. So let's begin. I already covered a little bit of this, Marco as well. So I'm Ilija. I've been a full-stack developer at CodeCamp since 2017. Before that, it was mostly just hobby stuff and a little projects here and there. As I said, not a PHP guy. Yeah, I will make jokes about PHP, and this is a bit invasive, but please don't get offended. So it's all in good humor, and I, like so many of you guys, also started with PHP a long time ago, because what's easier than creating index.php and then just echoing something, right? What? Yeah, that's why I do JS now. So. Okay, so let's go over the scope of what I'm going to be talking about today. So I usually do presentations on the most random topics, so excuse the loose navigation through what we're about to cover. So we're going to go over what a server is, why we need them, what an application is, what is PHP anyway, right? How does PHP translate into HTML, how do we host our PHP applications, and then we're going to talk about the first thing, well, not doing that anymore. So let's go. We're going to start off easy. We're first going to cover what a server is and all of these highlighted applications, and the last part is going to come in at the end. So even though I'm going to need your help for some of these things, just to do a sanity check on what I'm talking about. If I'm talking some random bullshit, then just let me know. So what is PHP? I don't know, so I looked up on Wikipedia and it said personal homepage. No, it really does, right? That's the initial name that PHP was given, and then someone went and renamed it to PHP Hypertext Preprocessor. So you guys took something that's named personal homepage and you said, let's build apps on that. Nice. So if we're going to go into building apps, right, we need to know how PHP is executed. So how is PHP executed? By running the CLI, right? And you can execute your PHP by giving it a file. But what is the most common way that you guys are running PHP? So I can see it here, so I'm going to use my mouse cursor to point. So the browser makes an HTTP request, for example, to index.php. And what happens then? Then you reach out to some web server. You don't reach out to PHP itself. You actually reach out to a web server who is a generic web server, really, because Nginx and Apache, they are not made specifically for PHP. They're not built for the explicit purpose, but both have mechanisms for rendering PHP applications and executing PHP code. And actually, what the most common method for this is, it's something called fast CGI. Fast, it means fast, and CGI, I think, means Common Gateway Interface, if I remember my things correctly. And PHP FPM, I don't know what the FPM is for, but it's basically one additional server that listens for requests and actually executes the PHP code that's, or actually the file that's requested from it, and then returns back the response. So that's essentially that's how your applications get executed. You have this generic web server, which you also unintentionally or intentionally use to serve your static files as well, because you don't have any code to say, if I go to img image and give me that image, you don't have any code that explicitly says serve this file. In general, sometimes you do, if you use a framework or something. But what happens is your PHP code only gets touched after, in this sequence diagram, after this point. Like after it went from the browser into the web server, and then the web server, through the method of integration, made a request to PHP FPM, which then runs your code and then returns, which can then go to the database, do some stuff, and get the rendered. it says HTML here, but it may not be. It could be JSON or whatever you want to do, right? So how do we host a PHP app? We made it. We have all of this awesome code that knows how to figure out what to do with, let's say, a route or something, and then it can return the appropriate pretty HTML, with maybe a React application or something like that, whatever, right? We host it on servers. So I don't actually have a slide for what a server is, but if we go back a little bit, I mentioned the word server a couple of times here. So Nginx and Apache is a server, PHP APM is a server. Also, MySQL as well is a server. When we talk about servers in this context, we talk about servers as an application, as something that is constantly up. And actually, when Martin presented just before, you were seeing, server listening on port, this and that, right? And that means that our application is opening a socket on a specific port and listening for any traffic that comes in on that port, and then figures out what to do with the appropriate string, right? If, for example, the thermostat, if it receives a command, it's going to do something, and it's going to write it to the database or something, and then put out a response. But a server is essentially something that's always running. It's constantly up. It's listening to traffic on a port, and it's constantly trying to read what's there, do something with that information, then bring back a response. Essentially, serve, right? Like a server, like a Kellner. It's constantly listening for orders and doing something. Yeah. In this case, all of these are applications that do that listen to a port, but it can be used in the context of an actual physical machine. It can be a virtual machine. It can be anything. So server is a very loaded term. So we're going to talk about all of the different uses of a server, like both as a VM, both as a VM, VPS, whatever you want to call it, your machine, this server right here, and as well as the applications themselves. And we're actually going to go over the distinctions, because that's actually going to be a key point in what this talk is about. So let's get back to the servers, but okay. So you want to serve your application, and you have a ton of different options. So I listed a couple here, like you have a managed servers, WordPress.com, where you can, you have some form of WordPress with a lot of customizations and logic about how to host multiple websites and how to handle traffic anywhere, right? When you create your own, you register for an account on WordPress.com, you get your own admin panel, custom domains, and all of that stuff, and all of that is their additional layer on top of WordPress. Then you have, and this is actually, if you just want to have a WordPress instance, this is probably the easiest, the most painless way, but it also limits you into what WordPress.com will allow you to install in terms of plugins and actually what type of code you can run on that. And then we go into possibly the worst and most limited option, which is shared hosting. And then we have the next level of VPSs, virtual private servers, and VMs, which is just a virtual machine running on someone else's machine. And here, the headaches can begin, because now you have a full Linux machine. Usually it can be Windows, but it's usually Linux. So this is where you have to get into sysadmin and DevOps and stuff like that, and you have to learn Bash now and learn what Nginx is and how to configure it, and then you have a headache. Or you're pretty rich, or you work for a rich company, and then you have a DevOps, and they do that for you, right? And the dedicated server is, where you actually either pay someone to host your physical machine somewhere in a data center, or you're, how do I put this, crazy enough to have a machine hosted in your basement, like we do in Base 42, which we do. Actually a cluster of machines over there, so everything, all of the infrastructure is hosted in here, in that corner over there. So if you just pull out the power cord, it's gonna go down. Yeah, and this is what we call infrastructure. And I've this presentation is a mishmash of a lot of other talks I've done. So I talk about infrastructure a lot, even on meetups that are not related to infrastructure, like this one and Beer.js. So yeah. So here are your options, right? In general, other than the managed services, these are your options. And I wanted to pull this image out as a way to illustrate what the different types of hosting actually look like, right? So we have shared hosting where you have, well, your hosting provider actually has one physical machine usually, or it can even be a VM, and they essentially rent out to you a little bit of compute, a little bit of disk space, and a little bit of memory to actually run your PHP code. This is very easy to use. It's probably what, there's even free options for this, and it's probably what you started with, right? It gives you something like cPanel or Plesk or something like that that gives you an easy to use, intuitive UI over everything, and you don't even need to know that what a server is, how to connect to it. You just know that, hey, download FileZilla, connect to the server, drop the files here, and boom, my website is up. And then you get your cousin that knows about computers to connect the domain and stuff like that. Okay, so I touched a little bit on this with the VPS side. It's pretty much the same thing, but the hosting provider in this case gives you a bit more dedicated control. With the shared hosting, you're basically in an isolated environment where you don't have much freedom to do what you want. You don't have the freedom to execute any code you want. You're basically, it's literally called a jail. So you're in a shell jail that limits you in what you can execute, what permissions you have, what you can and cannot run. And also, you know, PHP requires extensions and stuff like that sometimes. So you're limited into what you can use, what versions of PHP are there, and you rely on your host provider not being out of date. And you also trust them a lot to take care of security, which not a lot of them do take seriously, especially the cheaper and the smaller ones. But hey, with the VPS, you get a virtual machine, which is basically just your very own machine where you can connect to it, and it's essentially your computer, but at someone else's basement, right? And you connect to it with SSH and do whatever you want, and then it can either come pre-installed with some stuff, or you can, you know, here's your machine, do whatever you want with it, right? And that's also on one big machine that you get an allocation of, again, CPU, RAM, and disk space on. And then we get to the final boss, which is dedicated, which you basically have a machine, and it's, you know, it's yours now, so do whatever you want with it. And that means that everything is your responsibility. Even if the hard drive fails, it's your fault. You don't have any type of guarantees with this one most of the time. So I forgot that I actually made slides for all of these points, so we're just going to go over them one by one. So let me ask you something. Where does the load go? And what I mean by that is, say you host your application on any one of these options, right? And you get an influx of a certain amount of users. What gets loaded in this case? What needs to take care of that traffic? So in the shared hosting, you can imagine that as a machine. Let's say my laptop, right? If it's a shared server, right? It's hosting like maybe 100 websites, and it's shared hosting usually relies on none of the websites being that high in demand. And if there's a traffic spike, it can get completely shut down, and you wouldn't even get the request, so you would even get your account suspended sometimes. And that's, you know, a measure of how hosts have to deal with demand and being able to price things cheaply. On a VPS, it's usually the same thing, but you won't get shut down. You just get what you get, right? You get one CPU core, for example, 2 gigs of RAM, and if you exceed it, that's your problem, right? If your server stops responding, it's your problem. And the same thing on the dedicated machines. With the VPS, still you can get limited because you still have to share the network, right? Because the network is going to go to the same physical machine, and you have to share that. So you can still get shut down with the dedicated machine. It's usually you have a lot more freedom to screw up. But again, the load always goes on you, and you have to figure out what to do if you get a large influx of users. You either need to buy a better hosting package for shared. You either need to upgrade your VPS in that case. And with a dedicated server, well, you most likely need to get a new one because it's not that easy to scale, right? Or get multiple ones and figure out how to balance between them. Same thing with VPS. Actually, shared is the only place where you're limited, but that requires a lot of knowledge about infrastructure, about scaling, about networking, and stuff like that. And I don't think any of us have the time for that unless you're really into that. So again, these are just the key points that we all already went over. Essentially, you have no infrastructure with the managed service. It's the easiest to use, as I mentioned, but you're also very limited into what it is. And for example, I don't know, do you have something like this for a generic application like Laravel? No? Yeah, it wouldn't even make sense because Laravel is just a framework. You can build whatever you want, and no one can predict. Yeah? You can host Laravel on WordPress engine? No. WP engine? Oh, yeah. In shared hosting, you can. If you got lucky with the appropriate extensions and the appropriate permissions, you can technically run Laravel, but you're going to have a lot of trouble anyways because you usually will need to do some additional configuration. But when I say managed service, I actually mean a completely managed service like WordPress.com. Yes? They are building one. Nice. I mean, I know about Laravel Forge, but that's a completely different thing, right? Laravel Cloud. Oh, okay, that's cool. Yeah, but still in that case, you probably won't be able to run. Well, probably Symfony, yes, but I don't know what's another framework. CodeIgniter, right? You probably won't be able to run CodeIgniter on Laravel Cloud. Probably, maybe yes, but who knows? And you have a lot of stuff that helps you manage your own infrastructure, like the VPS. You have Laravel Forge, which can sit on your server and help you, give you a good UI and figure out what needs to go where and when something needs to get restarted and updated and stuff like that. But it's very difficult to do a generic platform. You have something like Heroku. I don't know if they have support for PHP, but yeah, then you have something that abstracts away infrastructure as well. But the most common is shared hosting, except for applications, usually for WordPress or some applications like that. And we went over the issues. Scales very poorly, actually not at all. If you get into the real limits, it can't scale because it's, again, shared stuff. It's not made to scale. And then you have this, as I mentioned. Here's your box. You take care of the rest. You can do whatever you want. And we expect you to know what you're doing. You need to install Linux, you need to install Apache Nginx, PHP, and everything, and then you also need to take care of security. If you think small hosts are bad at security, you're worse. You're always going to be worse, right? Because at least they have a dedicated guy who is going to, well, eat it for that. So, and again, this is not a PHP thing. Actually, you guys are very lucky because I can't find a shared hosting that's going to be willing to let me execute Node.js that easily. So every application faces the same issue. So let's go over the cloud, what the cloud is. I had a different slide here, but never mind. We'll figure it out. Can I see it? No. Now okay. So the cloud, the magic cloud. It's just someone else's computers, right? It's not your computer, it's someone else's. Okay, I had a transition. I forgot. I copied this. I copied this from another presentation, from a talk on CDK. So it's all of this guy's computers, right? This is Jeffrey. He has a lot of machines. He has so many of them that he's not able to use most of them, and actually he figured out how to make money on this before he figured out how to make money by selling products on Amazon.com. So yeah, there's tons of computers running on AWS. And so your applications, especially Laravel and stuff like that, they're going to need a queue, they're going to need, I don't know, some caching mechanism, they're going to need some databases and stuff like that, and then you need to scale that as well. And who has time for all of that? Not many people, but most people are willing to shell out a whole chunk of cash in order for the real money makers to actually run, right? The application is usually the business, so if that generates enough money, you can make this guy even richer, right? So, AWS Lambda. Lambda is one of the many many, and I can't say that enough because they have like so many services. One of the many services that AWS provides, and the Lambda is what's called function as a service. So the theory behind function as a service platforms like AWS Lambda is that they allow you to host essentially one piece of code. They say, okay, if you give us this function to execute, we have all of this infrastructure lying around anyway that's not being used, so we can ship it off here and run it somewhere, give you the results back, and we're not going to charge you because it's infrastructure that's laying around anyway, catching dust. So essentially, you have a single function, you implement whatever you want in that, and then that gets executed somewhere. You don't care where, you just care that it's Linux and that you have all of the necessities for your app to run, like PHP and stuff like that. So, function as a service takes care of scaling automatically, right? You don't care. Jeffrey has a lot of computers. He can figure out where to place the function that's executing while it's executing. It takes care of security, and if you look at the fine print, it actually just takes care of preventing people from being able to SSH into your machine because you forgot to set a password on your server or something like that. And this is the key thing. Actually, this is the main reason that you would actually pick this rather than paying for a virtual machine or something like that. This and the first point, actually, because you only pay for the time that the function is running. So you get 0 requests, you pay 0 monies. Yeah, that's a very, very good thing, and they have a very generous free tier. But this, for the time the function is running, can also work against you, because if you have a lot of traffic, then potentially you're going to have a big bill. But AWS Lambda as a service is theoretically relatively cheap. And in most cases, unless you have 100% usage of everything all of the time, it's going to pay out. And it's very rare that, unless you're like Netflix or something, where it's going to pay off to migrate off of Lambda and then go into EC2 machines, which is actually exactly what they did a couple of years ago, if I remember correctly. Sounds good? Yeah? You guys like this? Does it sound like a good idea? Too bad. It doesn't have any native PHP support. So it has Node.js, it has even C++ and Rust and stuff like that, but no native PHP support. So, yeah? Since when? Okay, then never mind, I'm closing the laptop and I'm going home. But yeah, that's really cool. Actually, okay, so today I'm going to talk about breath. Breath keeps your toilets clean until I'm scale and actually helps your app scale, right? Shit, that's the wrong breath. It's this breath. Breath, unfortunately, isn't the toilet cleaning solution. It's actually the simple and scalable PHP with serverless. And this is an open source framework that was built before Lambda had native support for PHP, which I didn't know. So that's a good takeaway, and it's going to give me something to do after I finish this talk, because I started migrating an application a while ago from EC2 into Lambda. Still not done. So if now it's native, then probably it's going to be a bit more easier to set up. Not that this wasn't, it's just that the application is very, very complex and has a lot of dependencies. So, okay, let me get back to breath. Okay, so a bit of context. Whenever you run your code, I mentioned that it has some necessities, right? It needs PHP, it needs whatever libraries your operating system needs and your dependencies use. And in order, Lambda is a generic platform, it needs to have support for all of that. And it actually has support for you implementing your own, it's called a runtime. For any language, even if it doesn't have support, you can sit down. If you implement their protocol on how your application is going to get, your code is actually going to get requested or executed, you can basically add any support for any language that you want, even without waiting for AWS to implement it themselves. They waited a long time to implement one of the most popular languages in the world, right? So, how does PHP get executed again, right? We go into the browser, then to Nginx, and then to PHP FPM, and then into MySQL. So, what is the entry point of all of this? when does your application actually get the request? We said it's here, right? And theoretically, what is preventing us from thinking about our application as basically just one function, right? Can we think about an application as just one function? A function is something that takes an input, does something, and then returns an output, right? That's a function. And what does our application do in the most common sense of the word? It usually gets a request, gets it on a URL with some specific parameters, query parameters, body stuff like that, with headers and all of that stuff, and it gets a response back. And then what? It just sits idle, doing nothing, right? Most of the time, unless you have some jobs in the background and stuff like that, but that's a separate topic. Bref also has support for that. So the theory here is that, we'll get to that. The theory is that if we can swap out all of this, right, and say we don't need Nginx and Apache. We just need, our application is just one function that will get executed with the same data that Nginx would pass through anyway. It's just not going to come from Nginx. It's going to come from another, I didn't have time to draw all of this, but it's going to come from another service from AWS called API Gateway. Because, as I said, right, Lambda is just a way to run specific code at specific times. And they provide something else that's called a serverless API Gateway that will only get executed when it receives a request. And then you can just, it's going to invoke your Lambda with the appropriate request options, with the appropriate body, URL, and stuff like that. And then I think we successfully summed up a PHP application as a function of a request, right? And just to help you visualize what this is, it's basically this. You're going to receive a JSON formatted requests. The JSON is going to include the URL, the body, the query parameters, the URL parameters, and all of that. And then you can just pass it through your whole pipeline, whether it's Laravel or whether you have your own kind of framework, whatever, right? And all of this is going to get served by Lambda, and then the request is going to go back. So it's not all sunshine and rainbows in Lambda land. We also have some limitations. Because we are running on Jeffrey's machines, right? And they can't really trust our code too much, and it gets shut down usually not immediately, but sometime after executing, right? Because it needs to be warmed up if you have a lot of traffic. And that means that we don't have any persistent disk space by default. You can add it, but it's not there by default, and it's not usually the pattern. But this type of this type of thinking, when you have these restrictions in your code base, it forces you to think about how your application stores things, how it stores state, how it reacts to that state. And this will force you to separate out the caching, separate out the file storage, and separate out the databases and all of that, and take care of those problems individually. And what do you know? Jeffrey has a service for that, right? They have a caching, they have databases, they even have serverless databases, and everything else that you can pay for and not have to care about that much. And yeah, so these are sort of the limitations, but they are, if I was working marketing in AWS, I would say they're forcing you to re-architect your application better so that it's stateless, so that it can be deployed in Kubernetes, because that's another place your application can get killed and not being cared for, right? And I think that's about it for the explaining part. I want to actually try it out and actually try to pray to the demo gods. You join me, and we can try out to deploy some PHP on Lambda right here and right now and see how that is going to go. Is it going to work, or is today just Friday the 13th? Whose idea was it to be Friday the 13th for PHP Skopje, guys? And why? Okay. Yeah? Bad idea. Anyway, so I'm going to just go over the documentation, because This is not something that I know by heart, so we're going to go open the documentation and we're going to see what the prerequisites are. I have all of the prerequisites set up. I have an AWS account. I already installed the serverless CLI, so after this you're going to just have, yeah. You're gonna need this. So, to deploy PHP on Lambda, you need a better language. Node.js and JavaScript. And the serverless library, and actually it's a sort of a framework that abstracts away how we provision all of these resources on AWS. So we have serverless installed, and by the way, use Node.js anyway when building with Laravel and Tailwind and all of that stuff. So yeah, you have to give me that. You don't, but I'm just gonna take it. So these are all of the prerequisites. I'm just gonna scroll over them. You can read them on your own time, not on my talk. And then I'm gonna show you 2 demos. I am very ambitious, and I'm going to show you 2 demos. One is going to be with just plain old PHP and nothing else. Just an empty directory, create index.php, deploy that somewhere, and be done with it. And then I'm going to deploy a Laravel application for fun. I'm just gonna create a directory called basic, right? I don't have anything else, it's just basic with 0 files. And here I am. So I'm just gonna follow along with the setup guide. And I'm just gonna say, I also have Composer installed and PHP. And yeah, this is going to create, what did it create? It just initialized the Bref dependency so that we can actually use now the Bref CLI. And okay, so we just run Bref init, and this is going. We have 2 options here. So one of them is web app, because running PHP on serverless is not always going to be about handling web requests and providing responses. It can be whatever you want it to be. It can be your application or your way of handling some, I don't know, processing some data maybe processing some videos, whatever you want, right? If you have a queue, if you have some events in that way that can trigger the Lambda, because a Lambda is just a function, it can get triggered whether by an HTTP request with API gateway, whether it's by some file being uploaded on S3, whether it's a queue event or whatever else. There's like a million triggers. You can do whatever you want, and that's going to be the event-driven function. We're just going to go with the basics and go with the web application. And yeah, now we have the web app, which is great. It's just an HTML file, which is how we all started with programming, right? And it says, hello there. Very fun. What it also created is this serverless.yaml. And this YAML file is going to determine what we need, what our entry point is going to be, and what runtime it's going to use. So you can see it picked PHP 8.4 with FPM, and it's going to use index.php as the entry point. I'm going to keep everything else just default, and I'm going to change the name to base42-basic. And let's see. I'm just going to change my AWS profile, and then what are we going to do? Let me check the docs. Where's my? Here it is. Okay. Where's the thing? Yeah. Okay. What does it say? It just tells you what it did, and then we just run serverless deploy, and that should serverless deploy. And now we wait. So this is going to do a whole bunch of, oh yeah, one other limitation. You have 30 seconds to give back a response. If you need more than that, then you have bad code anyway, so you need to fix that. But that's a limitation of the API gateway itself and how that works. The Lambda itself has a maximum execution time of 15 minutes, but that's only going to come in if you have something event-driven or with some other trigger. So in the background, what this is doing is it's going to deploy a whole bunch of services. Yeah, here we go. Okay, never mind. So we have base 42 basic dev, right? And this is something that's called a CloudFormation stack. A lot of AWS keywords that I'm not going to bother explaining at this point. If you have some questions, ask me later. But we're going to see all of the resources that we would need to manually create actually being created at the moment. And we can see that at the moment, the Lambda function itself is being provisioned. So as soon as this is done, this is something fancy that's called infrastructure as code. As soon as this is done, we're going to have our application accessible. And there we go, actually. Let's see. Here we go. If I open this, hello there. And we don't have a server, we don't have a VM, we don't have anything. You can open this as much as you want. I'm just going to paste it in where I'm going to paste it in the Discord server, right? Did you know we have a Discord server you can join? You have some QR codes around the room. I'm just going to paste this to make sure that it actually loads and it's not just me, right? Here you go. By the way, you can do whatever you want in this Discord channel. You can ask for help, give help, and whatever else, right? And just for the fun of it, I'm going to hello PHP Skopje 3 and just deploy that again. And while this is deploying, I'm just going to go ahead and what do I do now? I wanted to make a Laravel app. Oh, wait, no. Laravel also has a CLI, right? No starter kit. I don't want to risk anything more. We are already on Friday the 13th, and let's choose MySQL, even though we're not going to do anything with the database at this moment. I don't want to deploy one. And yeah, this should have just created, this is from the Laravel docs, I didn't change anything. By the way, if you open this again, you should have hello PHP Skopje 3. Hello to you guys. And okay, so we actually have Laravel now, and I need to open the Laravel docs, right? So with Laravel, you start essentially with an existing application. This can be your app, it can be whatever else. It's not going to be a drop-in replacement unless you have a Laravel app that does absolutely nothing. It doesn't depend on a database, on queue, on storage, or anything else. You're going to have to read the docs and make the changes so that your file system driver is S3 and your queuing is something else and your caching is going to be Redis hosted somewhere. But you're going to have to do that, not me. So what we're going to do is we're just going to open Laravel, what we just created, right? I'm just going to close out this VS Code. And, you know, this is just a run-of-the-mill Laravel application, right? And what I'm going to do is, again, copy-paste from the docs. This is just going to install Bref again, the CLI, and it's also going to install something called the Bref Laravel Bridge, which is something that's going to help facilitate the way that your request will get forwarded to Laravel, and additionally some specifics and some, you know, sane defaults so that you can actually run your app. And let's see what this does. It should complete. Now, okay, and what does it say? We need to clear all of the we actually need to create the serverless YAML because it's not being created yet. And again, serverless.yaml. We have some additional information like environment variables, and you can see the syntax for doing that as well. And this is actually a bit interesting because it's not going to deploy one Lambda, it's actually going to deploy 2. Any guesses as to why? What does Laravel have that plain PHP doesn't? And what do you need to interact with your Laravel application most of the time? Artisan, the CLI. Because it needs to have the exact same configuration if it's going to tinker with your website, right? Hey, that's a CLI command from Artisan, right? Tinker? Was it? Yeah, I think so. Okay, so we have the serverless YAML, and you can see everything here is pretty much the same, just additional information and the additional service definition that is artisan. And I'm just going to change the service name again into base42.laravel. Yeah. Okay. What else did I need to do? I know that you need to do something about the config clear. Yeah, this one. Just remove some caches. I don't know if we even need to do that with a fresh app, but I'm going to deploy it. And this is going to take a bit longer to deploy because it's a bit of a bigger app. We have all of the dependencies and like 30 megabytes of framework that we need to ship. So this is, while this is packaging and cooking in the background, you can ask some questions if we have them. And by the way, this is going to fail because it's Friday the 13th, and I know why, because I tested it out before. But we'll fix it together. Yeah, but this one will. And I had the pleasure of figuring out why 5 minutes before the talk. So I did, and we'll figure it out together. Just so, because this is the samples, these are the docs, and you're going to go home, you're probably going to try it, and then it's not going to work, and then you're going to swear at me, and I don't want that. So we're going to fix it together. Marco, questions? Any questions, by the way? This is going to take a while. No. I thought so, but by default, the starter with no starter doesn't have any. Yeah, that's yes. Theoretically, it would, but this magic thing that we installed, the Laravel bridge, is actually going to take care of all of that, so that it doesn't fail. But usually, when you migrate an existing application, it's going to be headache after headache of figuring out why it's failing now and what I need to do to fix it. Yeah. Yeah. No questions?
Question?
I mean, it's a really funny thing why it's failing. I'm just gonna fix it while we wait. It's this actually. Yeah, because the latest version of Laravel actually requires at least 8.2, I think, and the CLI the CLI generates the serverless.yaml with the assumption for what was it, 8.1. Yeah, and that's the discrepancy, and that's why it's actually failing. I checked the logs before, and that was it. And yeah, we're just gonna let this deploy. I'm gonna do it again, and I'm going to send you the URL so that you have access to it, and we can see the Laravel application up and running. You also have events, you have queues you can implement. You actually have, let me just do this. You actually have, where was it? Never mind. I think it was in what Brev and serverless is. And you have a good matrix here of different use cases and the way that the performance, reliability, and simplicity is going to be in migrating your applications to serverless. So you can see you have full support for jobs and cron jobs and APIs for websites or legacy applications. Legacy applications is actually where this is going to fail, because you usually have a lot of dependencies, you usually have old PHP versions and stuff like that, and that's going to be difficult because Brev moves forward a lot, and now with native support for AWS, I don't really want to think about what you can't deploy, but for event-driven microservices, it's going to basically make your life very, very easy, because you don't have to care about how many, let's say, events I can process with my application, because you have all of Jeffrey's machines to do your bidding. And for real-time applications, it's fine, it can work. API Gateway has support for that via WebSockets and stuff like that, but it's not what it was meant to do. And PHP itself isn't really the best candidate to do real-time applications, but still. Yeah, and if we open this internal server error, if I go to Chrome, and if I find the stack, here it is. Okay, resources, and then I can open my where is it? This is the execution row, and that is the artisan, and this is the web function, right? If we go in here, we can go into our monitoring. We have cloud logs, right? We don't have to SSH into anything. And yeah, theoretically we should have our execution here, and it's going to just say, yeah, what I just spoiled for you, but I'm just gonna do this again, and in a while it's going to update. In the meantime, I can just send you the URL, not that you're going to see anything important in it afterwards. It's just going to be, you know, the basic welcome page from Laravel. So yeah, around 2 more minutes for questions, and yeah. Any questions for the final time? Yes? Микрофонът само за да се слуша.
How does Bref execute opcache in the Lambda container?
Opcache is the memory caching thing, right?
Yeah. How does it handle that?
It doesn't.
It doesn't?
Yeah, it relies on something else being the cache, like Redis or something like that. Because, well, theoretically it can, because, so we said the Lambda is not running, that's why you're not paying anything for it, right? So it has a state of being warm and being cold, and you have something called the cold start. So if your Lambda hasn't been evoked for like 2 days, for example, it's going to be cold, it's going to be shut down, and when a request comes in, it's going to have to be provisioned somewhere and executed. And then after that, it's going to be kept warm so that any future requests are going to not sort of get impaired by that cold start time. And theoretically, I don't know the specifics about this, but if I were doing it, theoretically it should, the op cache should work until it gets actually completely destroyed, and then you lose everything essentially in that environment that your code just executed in.
Have you ever heard of Lambda's Firecracker performance?
Yeah, Firecracker is actually interesting because that's the these are not typical containers, they're actually micro VMs. That's Firecracker that Philip just said. So yeah, they're very, very performant. Very, very performant and almost instantaneous start. That's the pretty thing about this, because you get semi-instantaneous startups because it's in the milliseconds time. You don't need to wait for the VM to boot. It's just very, very quick to start, and that's why we get something like this. There we go. Anyone else?
Prashing?
How do you manage the PHP configuration? So
actually,
do you do it in Bref or something?
No.
In the YAML?
Yes. Actually, with this serverless YAML, you have a whole. This allows you to customize the PHP config as well. It's somewhere in the docs. I don't want to fiddle through it, but it's explained in the docs, and you can install also extensions, and you can do whatever you want. Because what happens? Actually, let me just say this. This is actually, what happens is it actually gets deployed as a Docker image. And you have the Docker image, you can do whatever you want with it, but you may need to actually customize it a little bit so that it has all of everything that's necessary that's not within the standard distribution of Bref.
This is actually just running similar to GitLab, for example, runner when you build application.
Yeah, pretty much.
For
yes.
every runner deployed on Kubernetes, and then you have I don't know, maybe 5 or 10 replicas, doesn't matter, and then you put a deployed job there, and
it goes to whichever one is free.
Yes. For every job starts.
Yeah, pretty much the exact same thing, only it's in milliseconds, the time of actually figuring out where to place it and actually getting the execution started. Because for GitLab, for example, the workers, you're going to need to find a free runner with the appropriate tags and stuff like that, and then it's going to get scheduled, and a whole bunch of ceremonies happen. Same thing with GitHub Actions. Theoretically, for the fun of it, you could implement this, a very, 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 very slow version of it on GitHub Actions. That would be a fun experiment. GitHub Actions as a service, so that it runs your code. Huh? Yeah. That would be a fun experiment. So when you receive a request, send out a job for GitHub Actions and send the response back when it's done in 2 to 3 business days.
Прашање имам уште? Океј, во тој случај еден аплауз за Илија. Уште еднаш фала на Base42 што ни овозможија PHP третото издание да биде тука. Имаме уште некои пива останати, слободно земете и можеме целиот муабет да го направиме надвор. И среќна нова година!
Hey.